Well, hello everyone. Welcome to our webinar entitled Geomatica Developer Case Study, Sysdeco Custom Geospatial Applications. In this webinar, pardon me, we'll look at how the Geomatica platform can be leveraged to develop custom geospatial applications by using the Python programming language and having access to all of PCI's functionality. To demonstrate how Geomatica Platform can be leveraged, we have Vera Costantini with us today from Sysdeco, who will describe how they made use of the Geomatica platform to develop custom geospatial applications to meet their processing requirements. So we're very excited to have Vera with us today and look forward to learning more about how Sysdeco has used the Geomatica platform to develop applications. So what we'll be seeing in today's webinar, we're going to begin with an overview of PCI's product with an emphasis on the Geomatica platform. Afterwards, we're going to look at the benefits of developing custom geospatial applications for either clients or for in-house processing. Then we're going to have a look at why choose the Python programming language to develop your geospatial apps. Then we're going to continue with an overview of the applications or some of the applications that Sysdeco has developed in-house, and then finish off with a demonstration of those applications that Sysdeco has developed. So following the presentation, we're going to have a Q&A period. So if you have any questions that you'd like to ask at any moment during the webinar, you can simply type those questions into the question panel, and we're going to address them at the end of the presentation. So on today's webinar, you have myself, Jean-Sébastien Bouffard. I've been working at PCI Geomatics for approximately 5 years now as a technical solution specialist. And my responsibilities include supporting the sales team with all the technical matters, providing SME guidance internally at PCI, product training, and marketing material development. With us today is Vera Costantini from Sysdeco. And Vera has been working in the geospatial industry for more than a decade and has worked at Sysdeco since 2006 as a software specialist. In her role, she's responsible for product training, supporting sales, and image processing activities that can include stereoscopic DSM extraction, orthomosaicing, and land use land cover classification. Vera has an undergraduate degree in biology and a Master of Science in remote sensing in GIS. She has also experience in pre-sales, product training, and a tremendous amount of experience with PCI's technology. So quick note about Sysdeco. Sysdeco is an Italian company that provides a range of geospatial services and distributes optical and radar satellite imagery. And furthermore, Sysdeco has been PCI's partner and representative in Italy for over 25 years now. So both Sysdeco and PCI have a very strong, long-standing relationship. And we're very happy to have Vera from Sysdeco today on this webinar. So a few housekeeping items before we get started. During the webinar, all the lines are going to be muted during the presentation. And as I mentioned before, if you have any questions for myself or for Vera, you simply need to type those questions into the question panel, and we're going to address them at the end of the webinar. As well, if you have any technical issues, you can simply raise your hand during the webinar, and we're going to try and address those technical issues to the best of our ability. And as well, today's session is going to be recorded. So if you want to view this session again at a later date, you can log on to our website and download the webinar. But stick around for today. Now, before we get started with an overview or preamble of PCI's technology, we're just going to start off with our first poll. So we're just going to take a minute and launch this poll right now. So we'll just wait another 30 seconds and then we'll continue with the overview. 10 more seconds, and then we'll close the poll. Okay, so thank you for taking the time to answer that poll, and let's continue now. So to begin, a little overview of PCI's main products and its platform. What we have is our platform and our products presented in this framework right here. And we like to use this framework to sort of address how users, address the user's requirements in terms of their image processing needs, but also in regards to the throughput, the scalability, and the flexibility that that user requires for whatever their task may be. So on the left side of this framework, we have Geomatica. And Geomatica is our desktop product that provides users with the capability for photogrammetry applications. So that includes extracting surface models, filtering terrain models, collecting geometrical points, ortho mosaics, but it also includes image analysis capabilities. And that could be tasks like object-based classification, image filtering, atmosphere correction, deformation mapping, generating decomposition parameters, and much more. So Geomatica is really a full-rounded, full image processing analysis suite for optical and radar satellite imagery and for aerial imagery. Now, as users need higher throughput and need to scale upwards, we can meet those growing demands by either increasing the number of licenses of Geomatica, or we could look at other products, such as GXL. So on the other end of the spectrum, we have our GXL product, and that's a product intended for high volume production, but more on the photogrammetric side. So really, we're looking at applying the photogrammetric workflow and processing terabytes of data each day. And with the GXL system, it's very easy to scale up or scale down depending on your requirements. Now at the center of the framework right here, we have our GDE, or Geomatica Developer Edition. And this is our product that really puts the emphasis on Python and custom application development. So the GDE is where you gain a lot of flexibility in terms of what you can do with our products. So with the GDE, you can create your own custom workflows for whatever your application may be. Now at the core of all these products, we have the Geomatica Platform. So all these different products are using technology within the Geomatica Platform. And when you're using Python, you're able to access the Geomatica Platform and use all the different technology that's used between these products. And the focus on today is really on the Geomatica Platform and how that can be leveraged to develop custom applications. So to provide you with a little bit of an overview and a description of the Geomatica Platform, what the Geomatica Platform provides in terms of developing custom applications is really two main things. You have the Python API, and you have all these Geomatica functions that are available under the hood. So the Python API really allows you to sort of communicate with all the components of geospatial data and image products. So for example, using the API, you're able to read an image's metadata or write new metadata to that image. And that's very important if you want to create conditional logic where you could read an image's metadata and apply a certain process depending on values in that metadata. Furthermore, with the API, when you access your imagery, it's going to store all your imagery as a NumPy data structure. And that's very important because the NumPy data structure is the default Python format, the default format for images in Python. So because it's the default format, you're able to apply your own algorithms that you developed or applied other Python libraries for processing your imagery. So it's very convenient. Then in addition to the Python API, we have over 550 geomatic functions that could be used to develop whatever application that may be. So really the possibilities are endless in terms of what can be developed with all that technology. Now, in addition to the API and the 550 plus Geomatica functions, the platform provides a number of things. One is the ability for advanced function parameterization and heuristics. So really the ability to customize Geomatica functions more than what would be possible than in the GUI. So when you're sort of Using Python to access the Geomatica function, you have far more parameters that are available that are typically concealed in the GUI version of the software. And then as well, when you're using Python and the Geomatica API, you can develop heuristics and conditional logic to sort of build an application and a workflow. So this is going to add a level of intelligence to your applications. Next, we have automation. Now, because we're using Python, you're able to automate a lot of your processing. And this is one reason why a lot of our users want to develop their custom applications. Now, when you're doing automation with Python, you're not only limited to automating functions in sequence, but you can also automate functions in parallel. And when you automate functions in parallel, you're able to sort of make better use of the resources available on your system. And this is quite easy to do using the Python programming language and using some of the libraries like the multiprocessing library. Then we have interoperability. And interoperability is also very important for users that are often developing complex and more sophisticated geospatial solutions that require a combination of open source, proprietary, and their own in-house developed applications. So because we're using Python once again as sort of the driver for the Geomatica platform, you're able to much more easily create these sort of interoperable applications that are more complex. And then finally, we have develop and deploy geospatial cloud applications. And this is an item that has been gaining quite a bit of momentum the last couple of years. So a lot of our customers or a lot of our users want to be able to take our Geomatica platform, develop their custom application, and deploy that to the cloud. And often what we see, one of the main reasons why people want to deploy that to the cloud is to get the application or the processing chain closer to where the data resides. So you don't have to download your imagery, process it on your system, then re-upload it to the cloud to deliver your products to your customers. You want to have everything in one location on the cloud, so it's very quick to process all your data. So these are some of the benefits of the Geomatica platform. So when we put together all these different components of the Geomatica platform, this is what it looks like. So at the foundation of the platform, you have the Geomatica functions, the 550 plus Geomatica functions available. And this is really the basis of the Geomatica platform. Then on top of that, we have the developer environment where we find the Python API and Python. And this is where we leverage both Python and the API to define the processing logic and workflow for our application. So these two sort of steps right here, our bottom portions of the pyramid, are very important. Then on top of those, we have third-party integration and expert knowledge. So with expert knowledge, this is where you sort of make use of your SMEs internally to really fine-tune your application to get the best results possible. And then third-party integration is sort of interoperability, where we bring in different libraries and open source packages to create these more complex, these more well-rounded applications in Python. So considering all these different elements, we're able to sort of develop our custom geospatial solution. So this is all how it all comes together. So as I mentioned earlier, a big part of the Geomatica platform, well, one area of interest in the Geomatica platform is cloud deployment. So cloud processing has been gaining quite a bit of popularity when users want to develop and deploy their processing applications to the cloud to get closer to the data. So with the Geomatica platform, this is all possible as a result of Python being the driver behind the Geomatica platform. And that's because with Python, we're able to leverage and make use of third-party technology to sort of deploy our applications to the cloud. And I'm mainly speaking about the Docker application. So for those of you who are not familiar with Docker, Docker is an open source package that provides technology for virtualization and putting your application inside of a container to deploy to the cloud. And this can be done quite easily with Geomatica. So just to give you an idea of what that would look like, on the deployment side, from a user's desktop, there's really three main steps. One, the user would define their application, so they'd write all their code and write their logic to sort of handle the input and the output data. Then the second step, once that's done, they would put Geomatica and their custom code into a Docker container. And after it's inside of a Docker container, you simply need to deploy it to the cloud. So the process is quite simple. And at PCI, we have tools to help facilitate the task of deploying your custom workflows to the cloud. Now, before I pass it off to Vera, I just want to mention that we have a wealth of training material available online to get started with our Python API and Python with the Geomatica Platform. So our main site with all these training resources is the Developer Zone. So the Developer Zone contains training tutorials, documentation. It has a Geomatica cookbook that has tons of scripts. And it also has a community forum to help you get started by asking questions and have some of our experts answer those questions. So there's a wealth of resources available on the Developer Zone. So for example, we have the cookbook right here, where we have hundreds of different scripts where you can choose from there are hundreds of different scripts for either satellite image processing, image analysis, etc. And you can simply download some of these scripts, change the parameters, and apply them yourself. And then we have another page that I like quite a bit, and that's the tutorial page. And inside of the tutorial page, you're able to learn more about how to use the API. You're also able to learn how to do parallel processing, how to sort of manage metadata, apply your custom raster arithmetic, etc. So there's a wealth of knowledge available right here. Okay, so that concludes sort of a brief and quick rundown of the Geomatica platform. So now I'd like to pass it on to Vera for her portion of the presentation.
Okay, thank you, Jean. Hello, everyone. I'm Vera, and Jean already said, I think, the most important things about me and Sysdeco. And I'd like to thank Jean for arranging all the webinar, and also Stuart Wiseman for give us the chance to share our experience. Okay. Sorry. Okay, to start, the main reasons for developing custom applications, Jean already said most of the important things. For us, for our side, for Sysdeco, we acquire a lot of satellite imagery from many different providers for processing. And so it's important to automate these kind of processings. Many of our Geomatica customers perform the same task every time they acquire an image. So maybe pansharpening or GCP collection with a geocoded image. And so they felt the need to automate and reduce the processing time for this kind of tasks. And also, many users are not experts, so they wanted us to develop a simplified interface of the software, so that they do not have to learn all the software, but just the steps that they need. And there are also many other benefits of developing custom applications. Already Jean talked about it, but of course automation is the most important benefit, I think, because with automation you can execute a series of tasks with one click. And so this is, I think, this is the most important benefit. Also, the scheduling is very important because in this way, with scheduling, I can execute my workflow anytime, even if I'm not in office. For example, I can decide to process big data set during the weekend. And so this is not only for geospatial applications. This can be done with the programming language for any task, like downloading data from a website or sending an email, for example. This is a benefit of programming language in general. And Of course, for geospatial applications and the processing of imagery, developing a customized workflow is very important, because you can execute multiple functions in sequence, like, for example, clip an image and then do the pansharpening, and then, for example, ortho rectification, which this is what we did with our, for example, graphical interface in Sysdeco. And also you can decide to process the same, the many images with one task. Many images ortho rectified, for example. This is called batch processing, of course. Another benefit of developing custom applications is to create, as we already said, a graphical interface that can be something more user-friendly for non-expert users. This is here we see the first tab of the graphical interface that Sysdeco developed, and then we will see a demo live afterwards. So I'm not going to spend much time. We can, with this graphical interface, you can reduce or eliminate multiple steps that you should encounter in the software. For example, with the Ortho Engine, if you want to ortho rectify an image, you have to create a project, then you have to set the projection, load the images, and many other steps that you can avoid if you use a simplified graphical interface, of course. You can also tell your script to create a log file which gives you information about the process and the results, like the timing or many other information I can be interested in. And then also with few code lines, you can tell your script to send an email, send the log via email to one or more email address, and eventually also load the results on a cloud and send the link to the customer, for example. Another advantage of custom applications and programming languages is to launch an application or a software from any device. For example, nowadays everyone has a smartphone, so it makes sense to create an application that can launch a geospatial process, for example, like an ortho rectification. And this is what we did in one of our projects. Okay, now there is poll 2, so I should. Okay,
so I will start that up.
Okay.
So now we'll just take a moment to have a look at the second poll. And we'll just take a minute for that poll, and then we'll go back to the presentation. Okay, 10 more seconds, and then we'll close the poll. Okay.
Can I go ahead?
Yeah, you can continue now, Vera.
Okay, thank you. So, of many programming languages, why use Python? Of course, Python is integrated with Geomatica, as we saw, but also is a free and open source programming language. So, and even if it's free, is a high level programming language which allows to create complex functions. And most important for me is that it's easy to learn. What I didn't say is that I am not the developer of the script, and there is my colleague Francesco Fanelli, which is the person that developed the script, and I supported him because I'm the Geomatica expert, so the Geomatica user. So it was a teamwork. But I could see how easy it is to learn and use Python with Geomatica. In general, Python is a very easy programming language. For example, here we see the program Hello World, which make this writing appear on the screen. And these several programming manuals use it to show an example of a basic syntax. And here we see that, for example, with the C or Java, other two languages, you need at least 4 or 5 code lines to tell the script to print this writing on the screen. And with Python, it's just one line which says print hello world. So I can, even I that am not a developer, I can understand it. So it's very, very, very easy. And again, also it's easy to instantiate new variables and assign values. For example, in other languages, before you assign a value to a variable, you have to say if it's a boolean, an integer, a float, string, and etc. With Python, for example, we see that you just have to you just do it at once. So you say, for example, a equal 25, and the program understands that it is an integer, for example. And again, also mathematical operation are very, very simple and so much more easier than other languages. Geomatica and Python together, so with them together, you can easily execute many different tasks and workflows. As already Jean said, on PCI Geomatics website, you have access to a lot of information. And most important, examples of scripts from which you can take, you can start, and that's what we did. We took the examples on the website, and from that we start developing our scripts. So, for example, for Sysdeco, the most important workflow, for example, is ortho rectification. So we started from this from a script that was used to ortho rectify COMSAT 3 imagery. And as it says in the website, the first step is to import Geomatica modules. You have to know what steps you have to do in your script and import the modules that you are going to use, and also set all the directories and path names, so the folders where all the input data are and the output data will be. And of course, an ortho rectification workflow implies also some steps to improve the model, like automatic ground control and typoid collection, and automatic elimination of points with high RMS error, and eventually also a batch ortho rectification. So and that's what we did with the Android application. I'll show you later. And here we see, for example, a portion of the script, just to show you how how easy it is to create your own script. We took this the script from the website, and then we changed it with the parameters we needed. Okay, and for example, here we see that we use an AutoGCP module to collect ground control points from a reference source. And this other step is a GCP refinement that automatically identifies and eliminates ground control points with high RMS error. And another step is the next step is the where you choose the model. It can be a rigorous model or an RPC model, and then the ortho rectification itself. Just to go a little much deeper in the script, in the details of the script, you can see that in the Geomatica Help you have all the information you need to create your own script, because there are all the parameters you have to set, and the possible values if a parameter is compulsory or optional. So it's quite the Geomatica Help, it's very detailed and complete. And here, for example, we see again for the auto GCP step that this parameter mean score just means the minimum acceptance score for the collection of GCPs from the geocoded image. So you can choose a number that is between 0 and 1. The search parameter just means the maximum number of GCPs. So you can choose the number you prefer. It depends on the size of the image and many other things. And again, for this other step, the refinement of the GCPs. For example, here, this parameter reject as 3 number 4 2 2. If we see the script like this, we can ask ourselves what's the meaning of these numbers. But if we go in the Geomatica Help, we'll see that the first number is the mode of rejection, and you can choose between if I remember correctly, like 5 different numbers, 1 to 5, which are correlated to the rejection mode you choose. And the second and the third parameter is just the minimum absolute pixel residual for X and Y. So if you go in the help, you find all the information you need to create the script. But let's go to the projects that Sysdeco developed to show you some demo live, which is maybe a little more interesting. So we worked on 2 projects and to address important requirements, which were increasing automation of our rectification workflow, also quickly process large data sets with a single click, and creating simplified interface for non-expert users. So the graphical interface was developed to perform different tasks, clipping, pansharpening, and ortho rectification. And the Android application was developed for remotely initializing batch processing. So just click with one click, process many images from a smartphone device. The graphical interface, I'll go very fast and then I'll go to the live demo. This is made by 4 different tabs. The first one is in Italian, I know. It's just a description of the tool and of the steps that are in this tool. All the steps can be performed in a sequence or not. You can clip an image, okay, and then pansharpen the same image and then ortho rectify, or you can do every step separately, okay. And I think I'll go to the live demo so that you can see the graphical interface. So just a sec. I hope you can see my screen. You'll see the Python script here. I will launch it. And the graphical interface is launched. Okay. So as I told you in the presentation, you can see the first tab with the description. You can put whatever you want, of course. Then we go to the first step. Here in this demo, we are going to perform a clip of multispectral and panchromatic image of the same sensor, in particular COMSA3 image. And then we are going to pansharpen this data and then ortho rectify them. So the first input is the multispectral dataset. we converted the original file in a PIX format just to make things easier for the demo. We are going to use a mask to clip the image, of course. So we're going to choose a mask and then an output folder. And then a file name, for example, Olbia is the name of a city in Sardinia. So we're going to call it, today is 27, okay. And the format is okay, the PIX. So it should be, it's very, very fast. It's just 2 seconds. Then here we want to clip with the same mask also the panchromatic image. So we're going to change here only the input, ComSat, pan, okay. The mask is still the same. The output folder is still the same. And for the output file, we are going just to change this name and clip. As you can see here in the results window, you have all the information in Italian, I'm sorry. It just says that the file was clipped and where is the output, okay? I click reset and then I'll go to the next step, the pansharpening. The first input is a multi-band file, so the multispectral file we just created. Results, I'm going to choose the last file created, okay. For the input panchromatic file, we're going to choose the other file created, panchromatic one. Again, we choose the output folder, which is, okay, results, and a file name. So Olbia, PS, yes, maybe clip, and just the date, just to be, okay. And I'll click pansharp. This step is going to take a little bit more because the pansharpening algorithm is a quite it performs a fusion between color image and panchromatic image, so it can take a little bit. That's why I clipped the images before, just to make the thing a little bit more quick. And what is important here is that the clip and the pansharpening steps are created in a way with the script that they keep all the orbital information in the pansharpened data that will be output, and so that the data can be ortho-rectified. Okay, and this is not if you do it without a script, you have to add the orbital information in the PIX file after you created the pansharpened, for example. So it is not an automatic execution, okay? Okay, so again, we have the processing time, which is about 2 minutes, right? And from here, which is important, is that we can launch focus. So we are going to launch it, and the image will be displayed. As you can see, it's still a not ortho-rectified image, okay? And if we go in the Files tab, we can see that we have the raster with the 4 bands and also the orbit information and the rational functions model segment. Just to show you that the image is pansharpened. Okay, I'll close focus. Okay, come back to my graphical interface, and I'll go to the ortho rectification panel. Here I can choose between two different ground control source, geocoded image or text file, if I have GCPs in a text file. Okay, in this case, I'm going to choose a geocoded image. And the input image is the image to be ortho-rectified, which is the last one we created, the pansharpened data. The georeferenced image, we chose to use Sentinel dataset because it can be used in a manifest.save format, the original one. And Sentinel-2 is a very useful dataset because it has a very it's a global coverage. The images are already ortho-rectified. Of course, the resolution difference between the two datasets is quite high. So, but this is what we had. So if you don't have anything better, okay. Now we choose also a DEM to ortho-rectify the image. And also we choose to save the ortho-rectified image in this folder. Okay. You can choose RPC or 210 model and maximum number of GCPs, which is, for example, 50, and also a minimum score for the correlation between georeferenced image and input image, and the maximum error. Since I think we are running out of time, I'm going to be a little faster. Okay, I click ortho rectify. Here in the results window, we can see that the GCPs collected are 6, and only 3 with an error lower than 2 pixels. So we just have 3 GCPs, and processing time is like 23 seconds. I will open the image very quick, and I also add a vector dataset of the streets just to show that the image was ortho-rectified. Okay. Okay. So I can close this. And very quick, I want to show the other way for the ortho-rectification, which was with a text file. I'm going to use another dataset, which is a Pleiad dataset of Geomatica. In this case, I will go to use a multispectral image. A DEM was created from the stereo pair, so with a much better resolution. And the input GCPs in a text file. Okay. Okay, just very quick. The projection is UTM 18, okay, and ortho-rectify. Here it only says GCPs collected because they were collected from the text file, and the 6 seconds of processing time. And here we can see the image ortho-rectified. Okay, so I'm going to close this. So reset this and close the application. I think we can go back to the presentation. And okay, the other project, very quickly, is the Android application. Actually, this is the one we are maybe more proud of. The infrastructure is a server machine where Python applications, data, and Geomatica software reside. An online database in MySQL database hosted on altervista.org, and an Android version 7 application. What it does, it performs ortho rectification using an RPC models by automatically collecting GCPs, again from a Sentinel-2 imagery. The important thing is the batch ortho rectification of these images. In particular, we use the COMSA3 and Pleiad imagery, but it can be done with any other imagery, of course. You can set important parameters, which are number of GCPs to collect and error tolerance. So more or less like the graphical interface, but performed from another device, from a smartphone. The processing steps are first of all to import your data in the database. So COMSA3 and Pleiad images in their XML format, and geocoded image of each area, of course, in manifest.save. Also, before launching the Android application, all the data must be imported using a Python script. So again, we use a Python script to import the data in the database. Okay. This is the online database, very simple, so that you can check your data set everywhere you are from any other computer. Even if you're not in office, the data will be in the computer, but you can check them from any other device. On the server machine, an Android and a Python script is launched and has to work in background so that the app works. On the smartphone, the app that we call GOrtho is launched, and the images to ortho rectify that are in the online database are showed in the app. So this is how the app looks like. Not all the images loaded in the database are always available because the app only shows the ones that are not ortho-rectified yet. Okay, so we can select one or more images. So this is the batch processing, of course. If you can also select all the images in the database. Two parameters of the ortho-rectification process can be set, as we already said, which is numbers of GCPs and maximum GCPs error accepted. Of course, the application can be implemented and improved, and other parameters we can introduce other menus to set other parameters, anything you can think of and that you can need. And the ortho-rectification process begins after the confirmation of the settings, and the data are actually processed by the Python script on the server machine, of course. On the online database, the image is processed at value 1 in the field lavorato, which means processed in Italian. So if we go in the online database, we can see that the images that were processed are actually have this value here. So we can check the processing. This is like a result like before with the Olbia. Here we have another example, a COMSA3 ortho image over Castelfusano area in Rome, overlapped to roads cartography, just to show the ortho rectification results. Now we should have the video demonstration where we can see actually the smartphone with the application. Okay, since I don't think you can. I think you cannot hear the voice. Okay, so I'm going to show you the video, and just maybe I will skip this part where we just show the Python script on the computer and the online database with the image. Maybe we can go to the part with the smartphone where we can actually see the application. I'm sorry. We're almost there. So the images are loaded in the database. This is the Python script that works in background. I didn't want to launch it actually on the machine, even if I could have done that, but just to be sure that it worked and that were no crashes, we decided to create this video. Okay, this is the application on the smartphone. This is what I wanted to show you actually. So here you can see all the images available. You can select them all or just two of them. These are the names of some cities in Italy, actually, where we have both COMSA 3 or Pleiad images. Click Next, and we choose the parameter. We set the parameter, number of GCPs, and maximum error. The important thing is that what we set for all the images that we select in this process. Okay, so here we select two images, Fusano and Vietri, which are two different places in Italy. Okay, so we confirm the settings, and after we confirm the settings, the ortho rectification is launched. It can take a while. It's processing actually is the script, the Python script. Okay, in the server there is processing the data set. But I can be with my smartphone everywhere, not in office. And the important thing is that the Python script is working in background on the server. Okay. And so it is processing. So the process is completed. And again, if I launch again the application on the smartphone now, I can see that the two images, Fusano and Vietri, are not available anymore because they were auto rectified. If I want to process them again with the other parameters, I should perform a resetting of the database, which is showed now. So I can see that they have this value 1, which is lavorato, which means processed. Okay. And if I reset the database, I go fast because I think we are out of time. Now, if I update the database, everything is 0, so all the image can be auto-rectified again. Okay, I think this is my last slide. Just to sum up, programming is a valued tool to speed up and improve data processing. It allows non-expert users to access high-level geospatial software as Geomatica, and also allows to launch process from any device, from any place you are at any moment, if you want. Customized application and graphic interfaces can be developed based on any other function and tool of Geomatica software. Okay, I think that's it from my side. Thank you very much.
Excellent. Thank you very much, Vera. That was a very informative presentation on how to leverage the platform with Python. I especially found it interesting how you had a dedicated processing machine set up. Oh, sorry, one second. And you're able to remotely activate that processing machine to process your data. So that was actually very interesting, and I'm sure a lot of our viewers found that interesting as well. Now, before we continue, we're just going to start up our last poll. and then we'll continue with a few items and then go to the question period. Okay, so a few more seconds for the poll. Okay, so now we'll close the poll and we'll continue on. So as I mentioned earlier, thank you very much for that presentation, Vera. It was very interesting. Now, before we move on to the QA session, I just want to remind you all that if you're interested in learning more about the Geomatica platform with Python and learning how to create your own custom applications, you have the developer zone that's available online. So that can be reached at dev.pcigeomatics.com/developer zone. And as I mentioned earlier, there's a wealth of information available on that website. Now, if you don't have Geomatica, you can download a 30-day trial of Geomatica at www.getgeomatica.com. And when you download your 30-day trial, you have full access to all the tools available within Geomatica. So you can download Geomatica and head to the developer zone and create your own custom scripts and give that a try. Now, PCI Geomatics, if you want to contact us or follow us, we're across different social media platforms. So we have an account on Twitter, Facebook, YouTube, and LinkedIn. You could sign up, register to those platforms, and follow us on those platforms. And if you have any more inquiries or questions, you could visit our website at www.pcigeomatics.com or email us at info@pcigeomatics.com. So now, before we finish up for today, we have a few questions that were asked during the session, and we'll go over those right now. And actually, there was one question that was for you, Vera. So one of the viewers asked, let me find the question. When you're giving your live demonstration earlier, they asked, is it the mask that defines the clipping area? So can you answer that?
Yes, the mask. The mask is the clipping area. Yes, is a vector. The vector, a vector area.
Okay,
like
excellent.
A shape file. Yeah.
Now another question that was asked earlier is, when we're going over the Geomatica platform, is how do you automate the generation of ground control points, DSM extraction, and eliminate GCPs with a high RMS error? Well, inside of the Geomatica platform, we have specific functions that you can call for automatic ground control point collection. And then we have tools that you can call for automatic removal and identification of the points that have high RMS error. And then we have a series of functions that you can call individually to extract a surface model and even go further and filter it to a terrain model. So all those processes exist within the Geomatica platform and can be accessed through Python. Now we'll do one more question before finishing up. One of the questions, is it possible to run DSM extraction in parallel? It is possible to run DSM extraction in parallel, depending on resources that are available on your computer. So using the Geomatica platform, using Python, you can call a series of sort of SGM DSM extraction functions, and then using functions available or libraries available in Python, like the multiprocessing library, you can run in parallel a lot of those functions together. So sort of the multiprocessing application of Python is sort of ubiquitous throughout the Geomatica platform. Now, we are running out of time, so if we hadn't had time to answer your question, we will get back to you by email. I hope everyone enjoyed today's webinar. If you want to view this webinar again at a later time, you can log on to our website at PCIGeomatics.com, go to resources in the webinar section, and download the webinar from there. Have a good day, everyone. Cheers.